Hello guys, welcome back to my channel. So as promised in earlier video, today we will learn about variance inflation factor, or also known as VIF. Okay, so in this video we will be discussing what is VIF, why it's important, how it can be calculated, and what is the use of in statistical analysis. Okay, so let's go ahead. So VIF is basically a parameter or a matrix to measure the degree of multicollinearity in a regression analysis. Okay, so basically VIF measures the degree on which two predictor variable are correlated with each other. Okay, so what does it means? Let's understand it by example. Suppose we have two column, call 1 or say age and say year of experience. Okay, so if both of these are correlated, so the older you are, the year of experience will be greater. Okay, so that is a common understanding. Okay, so what will happen, the more older you are, you will have the greater experience, correct? So these two variables are correlated to each other, and if we pass this type of data to our model, it will not help my model to train like very well or understand the like it will not improve the prediction. Okay, so what is multicollinearity? Multicollinearity means that there is a strong relationship between two or more predictor variables, which make it difficult to distinguish between the unique effect of each variable on the outcome. Okay, so because both are saying the same thing, correct? Okay, let me give you an example. Suppose we are interested in predicting the salary of the employee based on these variables. Let's take gender also, and based on these three variables, basically we want to predict the salary of a person. Okay, so here the multicollinearity between age and year of experience is very high, as per my previous statement. So we will ignore one of these columns in our model prediction. While we train our model as a predictor variable, we will eliminate one of these because keeping both of them is not helping us. Okay, suppose you are hiring you have a company, you own a company, and you are hiring people of same skill set only. Okay, so that will not help you. You need someone from backend, someone from front end technology, someone expert in data science. So need to have a like a collection of the skills in your company. You can't grow on only one variable. It's just an example. Okay, so as a result of multicollinearity, the regression model may not be able to accurately estimate the unique effect of age and year of experience on the salary, correct? So too much of theory, let's go ahead and see it in our code. So if you are following my videos, you know that we have trained a model, trained a logistic regression model, to be more specific, to predict whether a person will churn or not. So it's basically a database of telephone company. So now let calculate the VIF of the model we have trained. So for that we need, from a stat model, we need VIF. We need to import this library. Okay, and we will create a pandas data frame and we will pass the values of each column there. Okay, so see, I have created a pandas data frame VIF. In first column I am keeping the name of the columns, or you can say name of the features. Okay, in second column I am passing the values. Okay, and in third column I am calculating the VIF and I am putting it in the third column. Okay, and then I am sorting it according to the descending. Okay, descending manner. So let me print this. And if you see, phone service is having a VIF of 9.4. Total charges is having a VIF of 7.61. Okay, so anything above 5 is problematic. Okay, there is a boundary like 10 is a big red flag. So phone service is like too much correlated, so we'll eliminate that. So anything above 5 we will simply eliminate from our model. So let's do that. Okay, so let me drop this, and my let me print my column without phone service. So if you see, phone service is not there. Okay, it should not be there. Yeah. Okay, now let retrain our model. So I will not explain these code because I have already did that in my earlier videos. Okay, let train my model again. Let's see the summary. Now you can see the p values are normalized a little bit. Okay, now let's go ahead and again test the prediction, how we are getting the prediction. Okay, so first I will reshape the prediction to 1 minus 1, and then I will print the. Okay, so it's always predicted as 0. Okay, now let print the confusion matrix. So in my earlier video I have explained about what is confusion matrix. So let's match the overall accuracy here. Okay, so whether the accuracy will increase if we remove the highly correlated variable. No, because we are not adding data, we are just removing a value or removing a column from our model. Okay, we will just remove the redundant data from our model by doing this, by removing the VIF. Okay, so as you see, the accuracy is same as previously when we have trained our model. So if I go back, you can see the accuracy is same. There is no effect on the confusion matrix or on the accuracy part. Okay, now let's go ahead and delete the. Okay, before that let's check the VIF again. Okay, let's just check the VIF again, and now you can see total charges is having the VIF of 7.52. So we will delete this total charges also. Okay, so do the same thing. I will go ahead and delete this one. Okay, and retrain my model. Okay, shape the white trend parade. I'm just skipping all this code because I have explained it earlier also. Okay, now I am interested in showing you the confusion matrix once again while running all this code. Okay, it's again 0. Okay, now let me go ahead and run the confusion matrix. Sorry, generate the confusion matrix again. Okay, so let's run it. As you can see, the accuracy is little bit dropped from 8.819. It became like 810. So previously it was 819, 812, sorry. So it has been like dropped like very little. Okay, so as I told you, removing VIF features or removing the highly correlated features will not improve our accuracy. Okay, because we are not adding anything to our model, we are just removing the data from model. Okay, now let's again print the VIF. Okay, so as you can see, now everything looks under control. So all the VIF became like below 5. Now we are good with our model. So our final model accuracy is 0.810. Okay, so hope you understood the concept of VIFs, what VIF is, and how do we eliminate VIF from our model. So that's all for this video. Thanks you all. Bye bye.